Let's begin. So first of all, welcome everyone. Thank you so much for joining us today. So my name is Rishali and I'll be your host. Before we get started, a couple of quick notes to go over. So today's session again is being recorded, and we will send out the recording in the follow-up email after the event. So for this webinar, it's a webinar style format. So we will have a dedicated Q&A session at the end of the webinar where you can drop your questions in the chat box and we would be more than happy to answer those. So let's introduce the speakers for this session today. So I'm joined here by two of our Ceph experts at Clyso. We have Dan here, who is our CTO and co-chair of the Ceph project. And we have Josh, one of our expert developers, helping us build practical usable tools for Ceph and our Clyso enterprise tool. So over to you, Dan.
Thanks so much, Vishali. Good morning, everyone. Well, good morning from Vancouver. Good afternoon or good evening, wherever you are. So today we're going to dig deep into some of the things that we've learned and try to share some of what we do in the area of recovering CephFS clusters. So CephFS disaster recovery, deep dive, and then some one-click tools. And Josh is gonna help out with some demos and stuff. We're going to show a lot of stuff on the command line today. It'll be just a few slides, but then a lot of demo, and then lots of time for questions or Q&A. Getting things going. Just to set the context again before we go too deeply, I would assume that most of the people, or I would assume that everyone on this attending this webinar is a Ceph operator or Ceph curious or quite knowledgeable about Ceph already. The key thing to understand when we start to talk about CephFS is to remind ourselves that CephFS is an application. It's a Rados application. Ceph has it's Rados low-level object store, which is taking care of data consistency and replication, and erasure coding, and error recovery, and all these kind of things. And CephFS is, I can say, just an application on top of Rados. And it's an application that happens to turn this object storage into a POSIX-compatible file system, a network file system, something like NFS, something like Samba, something like all of the distributed file systems that we have. So it's very important. This is an important point because one of the fundamental things that we want to talk about when we talk about CephFS recovery is that the Rados cluster itself has to be important as the fundamental principle before doing anything else on top of CephFS. That's just setting some context. Now, the reason why we are doing this talk is because we're at Clyso, we're doing support, we're helping organizations build large Ceph installations, and we're kind of working at what I sometimes call like the bleeding edge of open source storage and distributed storage. One of the most complex things that we handle in our day to day is recovering CephFS clusters if there's been some kind of emergency. So we want to point out that recovering CephFS is probably the most complex type of emergency or incident that you can suffer in a Ceph environment. But once you start to understand how it all works, it becomes less scary, and that's basically the purpose of why we're doing this webinar. Getting into that disaster recovery itself, start with some fundamentals. So CephFS, it is a POSIX file system built on top of the low-level object store Rados. That's right. And then some other fundamentals, like we know in CephFS there's a metadata server, the MDS. The purpose of that MDS is that it acts something like a referee. It's ensuring the consistency, the POSIX level consistency that's needed, and it has this thing called capabilities that sometimes we see in warning message and things like that. Another kind of fundamental thing is that when the clients are dealing with, the metadata server is only dealing with metadata. It doesn't deal with any of the data itself. Clients, when they interact with a CephFS cluster, they're doing data transfer directly with the OSDs, bypassing the MDS. So it just goes directly to the OSDs. So that's kind of setting some fundamentals on how this all works. Before we get in, we're going to very quickly now get into some demos and explaining how this all works in real life. But before doing that, just want to set the stage of just the golden rules, what we consider the golden rules of recovering CephFS. In the case that you have an outage, that you have some CephFS clusters degraded, CephFS clusters listed failed or something like this, there's a there are some very important things that we always have to keep in mind. Number one, like always ensure before touching anything on the MDS or anything on the clients or anything before stopping things, restarting things, changing configuration, anything, it's essential to make sure that the underlying Rados cluster and all the PGs are healthy before attempting to do anything else. Several times we've seen in real life that CephFS outage is actually just some OSDs being down. And if someone goes and restarts MDSs trying to bring them online, it can make things actually worse than just get the PGs active and then magically CephFS will resume. So that's kind of golden rule number one. Golden rule number two is that anytime that we have in the Ceph project, we have lots of very detailed and sometimes simple, sometimes complex documentation about dealing with different types of CephFS warnings or recovery procedures. Those instructions having those instructions out there, sometimes I wonder if it does more to hurt recovery out there out in the wild than helping, because those procedures those tools and those commands they do very precise things. And for one thing is like they must be run in an exact precise order. They must complete successfully. You must not move to next steps without checking certain conditions. And the documentation is somehow incomplete, but it's like somehow as a golden rule, it's just like we say it like this. It has to be in the exact specified order, but there's much more to that as you'll see in our demos. And one of the last things is also that when you're framing in the frame of mind of of how this works, keep in mind that metadata is basically replaceable. So we can more or less reconstruct a metadata pool for a CephFS cluster from nothing, from the data. But any loss in the data pool, that's a permanent loss. We cannot recover data from the data pools. So avoid doing things that recreates PGs or wipes out PGs in the data pool, things like that. All right, so I think that's basically setting the stage, and it's demo time. So, and I'll hand this off. Josh will start sharing. Yep. But just as an outline, I can say that what we're going to do is we're going to go through different types of escalating complexity of incidents. I mean, Josh, do you want to explain what we're going to do, and then we'll go into a kind of a interview mode somehow. Yeah.
Yeah. So yeah, just a high level of what we'll be showing. So I'll be showing my screen. I have a Ceph cluster right in front of me, and we'll be kind of going through kind of disaster recovery. The first kind of demo, like Dan mentioned, is that we'll just kind of simulate a client accessing the file system and having inactive PGs, what that kind of looks like for the client, what that looks like for the file system, and what recovery looks like for that. So very kind of basics right there. And then we're going to go through as well, kind of just explaining what the CephFS journal is and kind of explaining what are inside the metadata inside the CephFS metadata pool. So kind of what are the Rados objects in there? What is the journal? What does it mean to flush the journal? What does it mean to lose the journal as well, and all that? And then we'll go through more advanced metadata procedures, like what does it mean to kind of lose, let's say the snapshots, let's say. What does it mean to take a snapshot and then kind of lose that? And then what does it mean to recover from that? And then we've kind of shared some scripts at the end to kind of automate the whole thing. So yeah. And I'll kind of just go ahead and share my screen here. Just let me know as well if the font size is too small. Hopefully it's not. And then before I do this as well, I will put this in the chat because, maybe I'll try to share it later as well, but I'll have the kind of the CephFS disaster recovery documentation right in front of me, or when we do it later. So you can kind of follow along as we kind of do it in order and step by step. Yeah, and that's kind of it to it. So yeah, So I have a Ceph cluster right in front of me right now. I'll kind of just kind of show everybody around here. It's a Ceph EDM cluster. This is a very small cluster, just 3 nodes on here. I have one CephFS on here, one OSD on each node, and I have a file system on here. On my right-hand screen here, I have a client. So I have a mounted client here. I can kind of show that as well. I have a client mounted on kind of this mount CephFS. I'm in this mount CephFS. Currently, the file system is empty. And I can go ahead and kind of like make a directory on here, directory here, and I'll kind of just simulate what it kind of looks like for a client when there are kind of inactive PGs in the cluster. So kind of just for this first demo, I'll just go ahead and kind of down the OSDs right here and see what that kind of looks like. So just kind of like setting like a no op. Make sure these OSDs don't come up and just down these OSDs to kind of simulate inactive PGs. Go ahead and do that. So you see kind of we have inactive PGs right here. What does the file system look like? Kind of here we have an MDS kind of still running, right? But if I'm on my client here, I can kind of still list this, but I'll probably not be able to make any files here. There we go. So if I was a client on this like Ceph cluster with kind of inactive PGs, MDS is kind of still up here and all that, but we have kind of inactive PGs right here. So kind of a bulk of kind of like kind of the disaster recovery for CephFS is kind of just making sure that the Rados cluster is all fine and all well. Again, this could kind of look very differently. In this scenario, I kind of just did this manually myself, but this could be kind of like crashing float OSDs, or it could be flapping OSDs up and down, kind of causing those inactive PGs and kind of like causing that kind of seeing what clients see here. So I'll go ahead and kind of just set this up now. We kind of go through.
Exactly. There was a quick question from Javier. Yeah, these are replicated pools. This one.
Yes, these are replicated pools, so we kind of go through that as well. So kind of like the main pools that we're kind of looking at here is pool 6 and pool 7. Kind of like the metadata pool and the data pool right here. These are kind of like size 3 replicated pools. And then I'm running kind of like latest tentacle here as well.
So it's important to note, if I may, this we see on your Ceph status at the top, this health warning that the MDS is reporting slow metadata IO and slow requests. This is exactly because, of course, that the PGs were down. So the client was actually, because you were just touching a file and then listing, there was no data involved in this, and it's simply that the MDS was not able to do what it's needed to do to persist the change that the client had tried to do. And then as soon as those PGs became active, the thing resumes. So this is this is sort of demo 1, right, Josh?
Yeah.
Yeah.
So I kind of just show here, kind of clusters all fine now. And kind of list stuff here as well. Yeah, and kind of the next thing we wanted to show is that before we kind of go into kind of disaster recovery, we kind of just wanted to explain what is inside this metadata pool. So we'll go ahead and kind of list these. Go ahead and kind of list the contents of this metadata pool and what is inside here, for example. So then what am I looking at here right now? What are kind of all these like Rados objects?
So these metadata objects, like, what is even metadata? Metadata is just, of course, it's data about data. It's effectively all of the objects that the MDS needs to store to understand the file system hierarchy. So which files are in which directories, what their dir layout is, which pools that they're stored in underneath, what extended attributes might be stored on those files. It's also things like the lists of all of the files that have been deleted recently, the files that are open by clients, the files. It's also the journals. So the journal is the in CephFS we have, and this next demo will be about showing the importance of the MDS journal. But like most modern high performance file systems, there was something like 20 years ago, we learned in file system development that it's important to be able to have high performance. It's important to use something like a sequential journal to instead of whenever a client is making a change to a file or a change to a file system, don't actually make the change directly. Just journal it somewhere. Just write that down in a notebook. And then later on, because it's very fast to write down that change in a notebook, and then later on asynchronously actually apply that change to the underlying file system. So that's the purpose of the journal. And a lot of these objects here, those are the journals, the 600 objects in particular. There's also something called the stray dir, which we won't get into this one, but there's things like the snap table, the inode table. Those we will get into because they often come up in the disaster recovery. But probably most important to show right now, interesting, is these are the directories. So we can actually see from your file system right now, it'd be interesting to look at what is in the directory of the root of the file system. And the directory is that one. Yeah, it's the 1.0000000. So that is the dir frag, or the first dir frag for inode 1, which is there. And you can see actually what's in that directory in the underlying object, exactly by listing the OMAP keys on this directory.
So yeah, so listing the OMAP keys for this directory, we kind of see that there's actually nothing in here.
No, there's some. I think you got the pool name wrong.
Did get the pool name wrong, I believe. Yeah, nice catch there. And I see I have a bunch of files on here that I've probably created previously.
Is that the
file
same?
system.
Is this the? Yeah. Okay. So this was. Yeah. So this. Okay. So we can show the change. So now it's a good time to see the purpose of the journal.
Yeah.
Right.
So kind of just before this demo, I've kind of emptied this file system, kind of deleted all the files, but probably not flushed the journal, and it has not persisted kind of to this root inode. So I'll go through kind of the situation of flushing the journal, what that kind of means. So we can flush the journal manually here by doing this specific tell command. I'll kind of just show what commands look like here. So we can kind of tell the MDS to kind of flush its journal properly right here. So if we do that, we've kind of told the MDS to flush its journal. And then let's go ahead and see what's inside this root inode. Kind of looks like it's still, there's kind of files in here.
Yeah. Because so I'll explain. I think I'll explain why later. But those objects are still existing because this file system has snapshots on it. And here we're working on those files exist in snapshot with snap ID 3. So we'll get into that in maybe demo the demo 3 or 4.
Yeah. So
but we very clearly see the directory entry Clyso _head, and that reflects what is there in this in what's visible by the client there on the right. Yeah. So exactly. So here we are. This is seeing some of the thing. Now so the important thing that this is showing, it's like, okay, so we have a journal, we flushed it. What does that all mean? What it's showing us is that when a client is doing some operations, there are the objects themselves, the metadata objects, the directory, the dir frags, they don't have all of the information. actually a client can create thousands of files, and all of the information, all the knowledge about those files existing is only in the journal. And this is like to underscore the importance that at different steps of the CephFS recovery, there's like people are sometimes tempted to reset the journal or wipe the journal, zero out the journal. If you do that without actually first recovering whatever was in that journal, like replaying that journal, then you've lost data, you've lost metadata. There may be thousands of files or changes to files or files that have been deleted or files that have been renamed or anything like this, and all of that information will be lost. So this is like, it's like lesson number one. It's like you must, the journal is not something that's disposable. It's critical. It's as critical as the metadata objects themselves. So you showed one way here, Josh, to flush the journal from a live thing. Let's now simulate something like, let's pretend that the MDS has failed. So first, so right now we know we flushed the journal, there's 0 entries in it, but create a few files in this directory.
So I'll create a bunch of files here, kind of just some empty files. I'll start from Z, not kind of confuse people.
Yeah. And then you can run sync on that client. So we know that the client has flushed it out, and now we'll fail the file system on the left. And we'll pretend that this has been some outage, and we'll fail that file system. Yeah. So now we're in this mode, and we can list that directory on the left again, the OMAP keys, and we will see that those, so X, Y, and Z are not there, but we just, as we were just explaining, they're in the journal. So how would we now, Josh, suppose that we were in a situation, we're not in a situation, but suppose we were in a situation where there was something like broken in the journal or something, and when we try to get our MDSs started, they just refuse to start, and we have some kind of understanding that maybe the journal's broken or something like this, and we want to reset the journal, but we know, because we just heard, that there's important data in the journal. First, we want to recover the entries. So this is how do we do this? This is basically the step one of the documented CephFS recovery procedures.
Yeah. So I have the kind of documented CephFS procedure right now, and just under the entry recovery from journal, I'll paste the command straight from the docs so folks can see. So this is kind of the command to say to the MDS to kind of flush the journal. I'll press enter in here. It won't work. It'll tell me I need to specify kind of which file system it is here. If this was a multi-active, if there's multiple MDSs on here, you'd have to tell each MDS to kind of flush its own journal. So since this is kind of like one active MDS, it could have been 0 here, or it could have been like all here as well. So I'll kind of go through what this looks like. That was relatively quick because there was only probably like 3 files in there. But we can kind of list what list OMAP keys again on this, and we can kind of see the files XYZ here that has been flushed. So in the event of, let's say, the MDS does not want to boot up, and client has been writing some files, which they probably have, kind of like the first step, if the MDS doesn't want to start up, is kind of make sure you just flush the journal.
Right. So now that you flushed it, it's okay to reset the journal, which is the next step in the recovery procedure.
Yeah. So if I were to boot up the MDS right now, it would go ahead and replay its journal again. So that's kind of like doing the same thing that we just did. So it's kind of important here that we'd want to reset the journal. So kind of just truncate it, or kind of just wipe it as well, or as the docs say, like kind of reset the journal here. So kind of like the same syntax here, kind of journal reset. And that was pretty quick as well.
So this is, and Kirk just asked a question, like, and it's a good question. So like, yes, this is this tool, CephFS journal tool, is interacting directly with the objects. It's somehow acting like a mini MDS like this. This tool won't even run if an MDS is running. The MDS would have exclusive locks on those objects, and this tool won't run. But the this tool sort of, it uses actually the same code to replay the journal. So now you've replayed it, and now we can set that cluster as joinable, and that cluster will work. So, and notice how some of those that might be reading ahead in the docs, like they might be like, "What? Hey, you didn't run the rest of the commands." I mean, that's actually the next demo now. So here we have and yes. So the question now, yes, the FS must be. You cannot run recovery tools while the file system is up.
Yeah, it won't let you here. So I'll copy this again. I'll do this, and it'll kind of complain that the file system is active here.
Yeah. So we'll go quickly now to the next step. So let's now assume that we've just blindly follow the instructions in the recovery. So let's again, Josh, if you might just create 2 or 3 more files in your file system. Yeah, yep. And then create a snapshot. Yep. Let's create a new snapshot.
There was my snapshot.
There's a little snapshot from preparing this earlier.
So I'll create another snapshot here.
Yeah. So now we have another snapshot, and there's the snapshot.
I'll just press sync this here.
And then run sync, but create a few more files so that there are a few files in the head that are different.
Yep.
Hard saying the alphabet in reverse. Voila. Okay, so now we're in a state where we've got a lot of things in the journal, and let's now fail the file system again. Let's pretend, oh no, we had another outage. We had another bug. Or a client did something weird. So now we failed once again. And now, let's quickly, you can show the objects again. You can list the OMAP. You can list the OMAP keys. So
trying to see it's not persisted here.
Not persisted. So let's flush the journal. So recover the entries again. And we can look again, and we'll see that those objects should be there.
Well, before this, I'll kind of list these.
Yeah, and we have some things there in snapshot 4. And
I will reset the journal as well.
Perfect. And then we'll keep going. And so some things in the documentation, it says, oh, you need to reset the inode table, and you need to reset the snap table, and you need to reset the session map, and then you should reset the file system. So let's do all those things and then see what happens.
Yeah. So kind of just resetting all this. And then again, you can do this for each MDS as well. So you can write all here as well. This is kind of a multi-active.
I want to just point out that this is this is very low level stuff, right? And I want to point out that this demo we're doing right now is to demonstrate that following the instructions without understanding what the commands do will make things worse. And that's what this demo is going to show, okay? So here we've just followed the instructions like because we're all expert like Ceph operators, and we follow this stuff and we think, and we're reading the thing, and it's like, okay, it says that to do this next, so we do this. And you can, I think the last command is to CephFS reset.
Yeah, I'll go ahead and do that as well.
So yes. Here we are. And now I think if you do CephFS status, the file system will already be active. There we go. So here we are. We have a file system active again because we've done the recovery. So now from your client on the right, let's see if it might be more effective on, Josh, if you, on the left, if you, well, it's already doing it. There we go. So, and if on the left, could you do like Ceph -W? With a lowercase w. So here we will see a file system has failed. Newly corrupted the entry. It's like there's something very wrong now. So we followed the instructions and there's something now very wrong. So actually what we did wrong is we reset the snap table and the inode table. Now, these two objects are important because they're very small objects. If you actually on the left, could you do the list, just list the objects in the pool again? Actually, that's just the Rados LS actually.
No, yeah.
So we have the snap table and the inode table. Well, these are very small objects. These are simply like a table. So they're like an array of they just keep track of which snapshot IDs and which inode numbers have already been allocated out. So in other words, it's like which snapshot IDs are free and which inode numbers are free, so that when we create a new snapshot or so when we create a new file, we make sure that it's not already used by something else. And in the recovery procedure, by zeroing those out, we actually we've just lost that information. So now we go on and like, how do I mean, earlier on in the presentation, we said metadata is always recoverable. So let's now show how we recover that metadata. And that's like in the docs, like this is the purpose of the next section of the recovery docs, where you need to do, it's the so-called CephFS data scan tooling. So we can go into that one.
So yeah, this MDS kind of just stuck in kind of connect.
Yeah, so we'll fail this file system and then we will run the CephFS data scan tools.
Yeah. So I'm looking at the documentation right now. So under recovery from missing metadata objects. So we'll kind of do all those steps right now. So kind of from here as well, then it'll kind of tell you to kind of force init as well, these objects, and we can go ahead and do that as well. And then doing kind of all these like sequentially, kind of scan extents here. These kind of finish very fast because probably wasn't not a lot of data. But usually on like a very big file system, these, especially scan links.
That scan links very critically just said exactly what we were just talking about. It's updated the last snap to snap ID 4.
Yeah.
And then we can clean up. The last one. Clean up. And then we can make the file system joinable.
So what did we just do then? Do we just recreate all the metadata objects? Is that what we did?
What we did is we scanned each of those commands. So scan extents, scan inode, scan links. So extents is actually, that's the data pool. It looks over all of the files in the data pool and it records something about it, notes down some information about those. Then scan inodes actually goes through and updates all of the inode objects in the metadata pool. Scan links then make sure everything is connected together and make sure that the inode table is up to date and that the snap table is up to date. And with that now, I mean, and we have a running file system. You can do CephMySW and we would see, so CephMySW is watching the cluster log and we would see, we'll basically see nothing here because from Ceph Health, we see that there were 9 daemons crashed. So that was just the MDS in a crash loop. And now we fixed this cluster, it's back. So we would go further and in a real recovery, we would do now what's called an online scrub by scrubbing the file system. We would go further, but the purpose of all these demos was to explain somehow that the documentation is there. And Anthony, I saw your comment to like invitation to update the docs. Of course, we're always seeking to update the docs. Somehow the point of all of this is to explain that recovering this stuff requires a deeper understanding of what's inside and how these tools work. We document the toolboxes, but then the toolkit, and the toolkit is all of these tools. Recovering the entries with the journal, scanning the data, And understanding that toolkit and how you use it and in which order, it can be very complex. And that was somehow this like golden rule that we were mentioning at the beginning as well. It's like things need to be done in the right order at the right time. It's not, and there's no one single thing that works every time. I'll say that, however, we've done our best. So with at Clyso here now, I think now we would show some tools that we've created to try to get closer to like a one-click CephFS recovery. If you could show, we can show one of those tools now.
Yeah. So I have in front of me as well as a script here. So we kind of have some pre-built containers. Similar, if you've ever operated like Ceph ADM cluster, we have some like pre-built toolbox containers that we call it. And this is kind of just kind of shell into the container. And we have some kind of pre-built tools in here. Oops. So I'm going to run my Ceph commands on here as well. So I think we wanted to simulate just taking another snapshot here, and then kind of deleting the snap table and kind of going through the whole.
Right. Yeah. So we'll, yeah, exactly. Quickly do the same thing and then simulate that same kind of error situation where we've reset the snap table. Yeah, exactly. So
so this
we forgot to fail the file system. So evidently we all just learned that you can run the CephFS table tool without on an active file system. So that's even very dangerous. It doesn't check. There's something for a low-hanging fruit improvement. So you could reset the snap table again to make sure it's really zeroed out. And then you can show. So now so everyone, I know this is like very complex stuff and people are seeing it probably for the first time. We're now in the same situation that we were 5 minutes ago, where we intentionally corrupted the file system. And then we demonstrated how we have to use CephFS data scan in order to get that file system running again. So right now, if we started this file system, it would be in a crash loop. But what we want to do now is show that we have written a one-liner that's available in our tool that we call Otto, and as part of this toolkit that we have. Our tools for Ceph, we can call it something like that, whatever sounds good. And this will now do exactly the same that Josh just did manually. There you go. Clyso, CephFS, recover metadata. And it has a bit more debugging. It has some parallelism, so you can use it on large file systems. It's doing this, it does the scan extents, then it does the scan inodes, and then it does the scan links, and it does the cleanup.
Yeah, some extra debugging kind of output as well, which is kind of nice.
And all of this is available in GitHub, the Clyso CLYSO GitHub account in the repository called Otto, OTTO. And maybe also there's that's where the Otto tool is, but the container is in, what's the name of the repository for the?
It should be Clyso tools container.
Clyso tools container.
Get a link here when I can. Yes, I'm just linked it. Thanks, Sam. And usually for very big file systems as well, kind of this recovery procedure, we've seen it kind of take like days. Rarely does it take a couple seconds. Maybe be lucky if it was a couple seconds. It's kind of more dependent on how big the file system is, how many objects there are, how many files there are.
So there's always a gotcha with this sort of stuff, as like maybe we've tried to say a few times, in doing this recovery. So we have all these tools, and we're happy to share them because we've all been there with the sweat coming down, feeling like, will we ever get the CephFS back online again? So we like to share this for this sort of reasons. In doing these kind of recoveries, quite often now, we've found that a lot of the earlier versions of the CephFS data scan tooling and CephFS, most of the CephFS data scan tool has some bugs in it whereby it has some kind of IO errors, or it's unable to fix some kind of corruptions. So this tool, like this tool that we've made available, if you're using everything and it's the latest version of stuff, it's going to be it's going to work. We can say that from what we experienced. Things get quite complex if you're trying to recover a Pacific or Quincy or Reef, and maybe even a squid cluster. There are some kinds of errors that the data scan and the other recovery tools in those versions, they're not able to repair. So that's just putting that, like, there's always a gotcha, there's always a footnote, and there is still that kind of scenario. So we always encourage, like, if you're using this tool, still, like, make sure you understand it, and try to pay very close attention to the log files and things like this. Anthony, you just asked the question, can you use newer tools for the older file systems? The answer is sometimes. Most of the time, well, it's just sometimes. So we have used newer versions and olders, but the most safe is to backport things. And we that's something that we have in progress. We have these container images that we have, like, one of the purposes of those is that we can backport things so that even in different versions, like in older versions, perhaps we have all of the fixed versions of these recovery tools also available for those. So just as always, just like if you need further, like, clarification or advice, just feel free to contact Clyso. There's a web form there to get in touch with us. I think that's the end of the demos. So then we'll switch back. Maybe I'll wrap things up quickly. Rishali will go to QR code and we can go to Q&A. So there we were, finishing the demos. Hope that was useful. So the key takeaways from this, the recovery can be complex. The different steps of this are very complex. If we simply do the manual data scan things, it can leave things broken. We didn't ever show a state there where we made things irreparably broken, but we could get there. There were some things that we could do that would make things even worse. So just, like, know what you're doing. Don't close your eyes and just press enter on the command. And we have these two tools. We shared in the chat there the URLs to these, but they're wrappers to help make this all a lot simpler and a lot more predictable than it was before. And with that, I think I'll hand it over to you, Rishali. Hand it back to you.
Perfect. Fantastic. Thank you so much, Dan and Josh. So we did have a lot of questions coming in through the chat box during the session as well. But now we're going to hop on to the Q&A session. So I think there's one question from Annie. Yes, that's the one that we have not answered. So how does this change if you have multiple MSDs per FS and each MSD is pinned to a given dir?
So thanks for the question, Annie. The tooling, indeed, we showed the example where there's just one rank active. So max MDS is set to 1. The tooling that we have shown there, so our Clyso tooling automatically handles the case with multiple MDSs. It's just very important. One error that we see quite often when like in errors that we used to make as well, like when we were studying all this stuff in the past, it might seem tempting sometimes while recovering a file system to just be like, oh, it's too complex. I'll just decrease to max MDS 1. Maybe I have 10 active MDSs and it's not recovering. I want to simplify things. I'll just make max MDS 1 and then that should make it simpler. Well, it doesn't actually make anything simpler because The fact is that when we have multiple MDSs active, each of those MDSs has their own journal. And that journal, like this is we are pinning, or we're using ephemeral pinning, or we're using the automatic heuristic to balance things across those active ranks. But each of those independent journals has critical information about the metadata. And we must recover the D entries from all of those journals before truncating them, and also before decreasing max MDS. So when Joss was showing the commands for recovering D entries and all of the data scan and stuff, there was where he was either typing rank 0 or he was typing the word all. Those word all, it means all of the ranks. So it will go through iteratively. And long story short, if you just use our tool, like it will discover this. It also discovers like what file systems are available, and it recovers all of those. Yeah. So I hope that answers the question.
There's one more question from Bonus. Are there still options if somehow you lost the metadata pool entirely?
Yeah, there are. So, and we didn't go into that because of the time restriction today. But in the documentation, the docs.ceph.com docs, the last section of that advanced metadata recovery, it explains exactly this. And what that is it's called recovery to an alternate set of pools. And sometimes we need to do this if we've lost the whole metadata pool, or maybe if we're in a kind of situation where we don't want the recovery tool to modify what's there in the metadata pool that we have, but we want to just like create some new metadata pools to just keep things safe. Like maybe this is a very critical file system. We don't want to we want to touch nothing as minimal as possible, make everything read-only, but we want to find a way that we can mount that, the existing, like reconstruct the metadata from scratch, mount it in a file system, and then probably copy it out to some other alternative storage. So that's the purpose of that recovery to alternate metadata pools. When we do these recoveries, we find that that procedure isn't perfect. And there are still some things that are lost. Sometimes maybe we've seen things like even like UIDs and things like this are lost, or maybe permissions on files are lost. And sometimes files end up in a lost and found directory in that case. So it's not perfect. And you want to avoid that. Try hard first to use the metadata pool that you have if you're in this kind of situation. But again, it's like when you're getting to that level, it's like I really encourage to contact someone that has done this several times before making a mistake that you'll then regret. So thanks for the question.
Okay. We have a question from Nick here. Is it possible to restore large storage pools with huge numbers of small files? And can this be done within a reasonable recovery window?
Yeah, so it was very interesting in one such scenario that we were helping a client a few weeks ago. It was at the point of recovering a file system that we needed to do this scan extents and scan inodes and scan links and then clean up. And that customer was actually, they were quite expert in like distributed computing themselves, and they had a large compute cluster that they were able to leverage to do the scanning of the CephFS. And if I remember correctly, so a lot of the CephFS data scan tools have a parallelism option. So you have parallel workers that just go out and scan all of the data extents in the data pool to try to reconstruct things. If I remember correctly, they had parallelism of around 1,000 workers, and they were able, I don't remember the exact numbers, but they were able to, with them, together I think it took 30 minutes to scan and recover the metadata, and effectively in that case, it was very similar to what we demoed today. The whole purpose of doing the scan data extents was just to get an accurate reflection of what the snap table and inode table were. And I think it took 30 minutes to scan probably 500 million files, something like this. So that was very interesting for me to see. Normally a scan like that, in the past I've seen scans like that take weeks to complete. So yes, you can parallelize a lot of it. Thanks for the question. Oh, you're muted.
Oh, I'm sorry. So we have one from Anthony. Is there a concern for ordering of recovery across multiple MDS journals?
That's a very good question. I have to think about it. I'm not sure. Very good question. That's a good one for homework. I would hope not, because in the end, MDSs can crash in any order. You can have power outages in any order. And anyway, an MDS can start at, an MDS will restart at any time, and an MDS journal can be flushed at any time. So I would assume not, Anthony, but let's just say that might be there might be some sneaky corner cases there.
Okay. We have a question from Fabian. What if in the setup, OSD devices would be broken and need to be replaced with new empty ones so that some data is lost? What strategy do you need to apply in order to recover as much data as possible?
So I suppose that one's somehow relatively simple. The answer is it depends. So if the OSDs, if you've lost OSDs, you said that you've lost in your question. You said that you've lost OSDs and data was lost. So what that means is that, let's say in our triple location, it means that you've lost 3 OSDs, and those 3 OSDs unluckily were having some PGs. They were the only OSDs having some PGs. So this is, again, very unlikely. And if you look through our repository, you'll find some data durability calculators and stuff to calculate the likelihood of such a thing. Normally in a well-configured Ceph cluster, this is never going to happen in our lifetimes. But if it were to happen, yes, now you've lost data. So if it was data objects, you've lost the extents, you've lost the data for those. And even if you do recover, like maybe you recover pointers for those, but the client's trying to read those files will just read back zeros instead of expecting the data that's expected. If it were metadata, it then depends what the metadata was. If they were some journal objects, then okay, you've lost some of the knowledge about the most recent changes to the file system. If it were directories, like dir frags, more technically, then you can recover those by doing the data scan commands that we've shown here today. So the answer is it depends, and I would say the better answer is to make sure that your pools are all configured correctly, and that you're testing things that you can reboot hosts and you can have power outages, and that all of your failure domains are good, and just avoid that thing from ever happening. That's the ideal scenario. So
can I add something to that too, Dan?
Yeah.
So usually if you have like 3 specific drives like fail, not all 3 of them are completely dead. Sometimes you can actually extract placement groups out of a mostly dead device and inject them back into your cluster, so you can actually recover from that situation.
Exactly. Yeah. Thanks for that, Brian. Exactly. Do all efforts to get the data out of the OSDs first. There's a one-liner, I think I saw on the mailing list this week, someone was saying, hey, can I just mark these lost? Is that okay? Like, that's like, Ceph makes it easy for you to kind of just say, Ceph makes it easy for you to declare that I have data loss, but it doesn't really, somehow we've gotten used to this, yes, I really mean it thing, and it feels like it's still okay. But when you type Ceph OSD lost, or you force create PGs and things, you're literally saying that it's like, I've lost all my data now. I just said all, maybe it's all. I've lost some of my data is more accurate, but maybe maybe you just lost the most critical thing, right? So I really try, like what Brian said, try to recover those OSDs first. How are we doing for time, Rishali?
We have only 4 minutes and we have 2 questions. So
okay,
we're going to quickly move to the next one. So we have a question from Rajiv. If MDS starts replay and MDS memory grows and host gets memory pressure / daemon fails / rank fails over, standby takes rank, standby starts replay from journal again, same cycle repeats, how to fix this issue?
Yeah, we've seen this one. This is, we've all been there, Rajiv. This is sometimes when the MDS is starting up, this is one of those scenarios that that motivate basically the very first demo that we did. Well, the second demo, not the Rados outage one, but the recovering the entries from the journal. What that normally means when you're having that kind of scenario is that in the effort to replay the journal, whatever the structure of the data is and those changes, the MDS actually isn't able to free up some of the memory that it's using in its cache or some other data structures in the memory while replaying, because if maybe there's going to be, probably in that journal, there's going to be some journal entry much later that then allows it to release some kind of lock or something like this. I'm talking about it in a very hand-wavy kind of way, but it's all to say that in that scenario, we would fail the file system, shut it down, use the tools to recover the de-entries from the journal, replay them, truncate the journal, so now there's nothing in the journal, and start the file system again. And this time, the MDSs will start immediately because there's nothing to replay and they'll consume no memory. And there are some other tricks that we can do to reduce the memory, including like the MDS is always like preloading the directory entries and things like this from the files that were open the last time that it was running. And we can, this is all stuff that is not that important. So there are a few tricks that we can do, but primarily I would recover the de-entries from the journal in that scenario.
Perfect. We have one last question from Constantine. How often are you asked to troubleshoot or recover CephFS compared with other Ceph components? Do CephFS issues occur more frequently?
Answering that question, I'm a scientist, so it's hard for me to answer questions like that without scientific objective data. It's more like, so in Ceph, like Rados issues happen sometimes. Very rarely do we are there issues with RBDE, because that code is very, very mature. It's the most mature in Ceph, and it's the most simple as well. We tend to get support requests for RGW because that's a very complex. Even though S3 and object storage is supposed to be simple, in the end, all of what's inside of RGW, including life cycles and garbage collection and the different things to do with sharding, and like there's so much complex things in RGW that ends up being a support heavy topic. And then in CephFS, most of the work supporting CephFS is about something like what the customers would call it performance issues, but it's more about just like how multiple clients, many clients interacting on the file system and how that impacts each other, noisy neighbor type stuff. Those are the majority of the issues. Very rarely there's something like what we see today. I say very rarely. It still means it's like monthly or something like this, but it's mostly from, if you go to our website, if you scan this thing, you'll see we have an emergency support thing. It's that's for organizations that are not our customers, not our support customers. And that it's normally from those directions. So it's somehow like, someone's been building up CephFS for a long time, and then suddenly it breaks for some reason. And then when things eventually get configured in a way that's stable, all the config options are good, the workload is understood, things are kind of like built in a way that's known to work and be stable, this type of thing basically doesn't happen unless there are some unforeseen circumstances like major outages or hardware failures or concurrent things, drives failing all at the same time because of firmware bugs, things like that. Yeah.
So we have one last question, but we are out of time. Dan, do you think we can do that quickly, like the last one?
Sure. Yeah.
Perfect. So very hypothetical question here. It's from Annie. But since the MDS seems to just be a series of Rados objects, if you copied all the Rados objects from one CephFS metadata pool to another empty metadata pool, and in parentheses, and did the same with the data pool, would you then be able to rebuild a comparable FS from the new pools? Is this the logic underlying the CephFS mirror command? And parentheses again, if you know, excuse the run-on sentence.
Yeah, it's okay. No worries about run-on sentences. That's we all in computer science world we can have an infinitely nesting stack, and we can keep track of this stuff. The CephFS mirror tool does not work like this. CephFS mirror tool actually works like a client. It leverages some speedups that we have, namely in all backup, regardless of the system, CephFS or anything else, the critical thing. So we know it's impossible to do a full backup nightly on a 100 petabyte file system with 10 billion files. It's impossible. If starting from scratch, right? So we need to have this concept of delta backups or incremental backups, which means that we need tooling, we need speed ups in order to be able to discover what has changed in the last 24 hours or in the last 5 minutes. We need to be able to do that in somehow like 01 time, which means like we need to be able to always within say 30 seconds know, tell me the 10 million files that have changed in the last 5 minutes, and then I'll just copy those over. So CephFS mirror leverages some tooling internally. There was this snap diff was a command recently implemented, and I mean, actually, it might not even use that, but it's just like it can go over and like iterate over all the files. But there are like ways that we can do this. What you're talking about is something very interesting that we think about a lot. Is there a way from the bottom, from the Rados cluster, to do this much more efficiently? And the answer is like not yet. And it's not yet because in the end, it's the same thing. In these clusters, we had very few objects, but in your clusters, you'll have tens of millions or hundreds of millions of Rados objects. And you need to be able to, in order to do that, you could back up a cluster like you're asking, Annie, if you could tell me which are the 10,000 objects out of 100 million that were modified right in the last 5 minutes, and you need to be able to somehow like snapshot those objects all at the same time and copy them over in one consistent view. You know, in different contexts, this is called a consistency group. So they need to be like in sync with each other, because if one is pointing to something but the other one is actually 5 minutes behind or 5 minutes ahead, like that's not going to work. So we're thinking about ways that maybe in future we could have either some kind of notifications like system that just like asynchronously copies things over and replays a journal, a little bit like how the RGW mirroring works, or something that leverages maybe some kind of like pool, like a new kind of pool level snapshots where we could snapshot a whole Rados pool, quickly compute what's the difference between those two Rados pools, and then mirror that whole Rados pool over to another cluster. That would somehow be like, if we can do that, that would be like like it solves all problems in Ceph mirroring like once and for all, because it would be a Rados level replication thing. So I hope that helps explain why we can't do that now, but actually maybe in future we might be able to. Yes.
Okay, we are out of time. So before we wrap up, I just want to flag that the recording of today's session will be sent to you within our follow-up email. So please keep an eye out on your inbox. The follow-up email will also have a short feedback form. It also has an option to like put in some topics that you would be interested to have in the future. So that's something you can feel free to go ahead and like fill that up. And yeah, thank you so much everyone for spending this time with us today. We really appreciate your engagement, and have a wonderful time, everyone.